Hello and welcome to Walking Talking Mocks with Budehaven Science. This video is going to look at how to construct a half equation and identifying reduction and oxidation. We will cover the subject knowledge you should have before answering this question. You will then pause the video and give yourself 3 minutes to answer an exam question, followed by an example answer from me. To answer this question, you'll need a pen, paper and something to time yourself with. We are now going to cover what is reduction and oxidation, displacement reactions, ionic compounds, showing ionic equations and showing half equations. With oxidation and reduction, we're considering movement of electrons. Because electrons are negative, losing them creates an overall more positive charge, and gaining them creates a negative charge. The mnemonic oil rig can help us to remember which is which. Oxidation is loss of electrons, and reduction is gain of electrons. The diagram uses a group 2 metal and a group 7 non-metal. The metal will lose its outer 2 electrons, while 2 atoms of the non-metal are going to gain an electron each. So in the compound, the charges are balanced out. Here our metal is oxidized and our non-metal is reduced. Oxidation and reduction occur within ionic compounds. This is because the metal loses electrons and the non-metals gain electrons during the bonding process. This is what forms the electrostatic attraction between the two. I've used a displacement reaction as an example. Calcium is more reactive than zinc, therefore it can displace the zinc from a solution of its salts. This leaves calcium fluoride in a solution and zinc as a metal solid. We now need to look at the charges on each component. I find it easier to do the ionic equation before the half equation, as it highlights where the electrons move from and to. An ionic equation only shows the ions that change in the reactants and products. A spectator ion is an ion that does not change from the reactants to the products. Don't let the format I've put up put you off. The zinc and fluorine are a solution, as is the calcium and fluorine on the other side. But separating the ionic compounds into its parts allows us to look at their charges separately and identify any spectator ions within the equation. Looking at the charges. Because calcium is an element, it has no charge at all. We can call that neutral. The zinc, however, has given 2 electrons to the fluorine, therefore it has a 2+ charge. There are also 2 fluorine atoms, each with a negative charge as they've taken on an electron each. On the product side of the reaction, the calcium has become 2+ charged. This means it has given 2 electrons away during the course of the reaction. These 2 electrons have gone to the fluorine, and the zinc has now become an element. This means it is neutral. We can see that fluorine has the same charge on each side. This makes it a spectator ion and will not be used in the final ionic equation. But both the calcium and the zinc have changed charge during the course of the reaction. These will be included in the final equation. Here is the final ionic equation. It shows that calcium has gone from an element to an ion with a 2+ charge. It also shows where the zinc has gone from an ion with a 2+ charge to zinc as an element. It's important that you remember these rules. Elements are always neutral because they have not lost any electrons. Metals will always be positive because they lose electrons, and non-metals will always be negative because they gain the electrons. And finally, here is how to construct your half equations. Here are your 2 half equations. In a half equation, we are showing the movement of electrons. Therefore, we show calcium as an element with no charge, going to calcium as a 2+ once it's lost its 2 electrons, and we show the electrons as separate products. The same process is used in showing the half equation for zinc. On the reactant side, zinc was an ion. Therefore, we're showing zinc with its 2+ charge and the 2 electrons that have been separated from it. On the product side, zinc is an element, therefore we're showing it without any charge at all. You now have the opportunity to answer this 3-mark exam question. You must pause the video in order to do this. Explain which species is reduced in the reaction between magnesium and iron chloride. Your answer should include the half equation for the reduction. Explain is a higher level skill. It requires you to give a reason for your answer. Pause the video now to try your own answer, and an example answer will follow from me. Here is my example answer. The iron is reduced over the course of the reaction because it gains electrons. The half equation for iron is Fe2+ plus 2 electrons gives you iron as an element. I have ensured that I've met the criteria for this question by only giving the half equation for the reduction of iron. I've also used the word because. This shows that I'm giving a reason for my answer. So the iron is reduced because it gains electrons. If you're still struggling with this topic, please see your teacher or come to one of our Wednesday revision sessions.